Welcome back to Grade 7 Geography, Unit Number 1, Physical Patterns in a Changing World. This is Lesson Number 3. How do we respond to challenges caused by Earth's forces? Natural disasters can be fun to watch in a TV show or a movie. We are very fortunate to live in a country where we have experienced far fewer natural disasters than other parts of the world. But the forces that create landforms can present great dangers to people, and this has to be taken seriously. In today's lesson, we are going to look at the dangers of earthquakes and volcanoes. And this shows you how old your old teacher is. I remember watching the great World Wrestling Federation tag team Earthquake and Typhoon. Together, they call themselves the Natural Disasters, and they wreaked havoc on the WWF for a number of years, but they have nothing to do with today's lesson. So, before I get too distracted, let's move on. Most large earthquakes happen in areas where plates are moving past or under each other. A prime example is where the edges of the Pacific plate meet the Eurasian, Australian, and American plates. This area is known as the Ring of Fire. This is a major earthquake zone which has also created a string of volcanoes that surround the Pacific Ocean. As you can see in this diagram right here, Circle of Fire is referring to this area that's in a darker pink. When plates meet, pressure builds and grows. Eventually, energy is released and shock waves shake the land. The epicenter is the point on Earth's surface directly above the location of an earthquake. After the initial shock wave, there is a series of smaller aftershocks. Shockwaves rarely injure people. However, shockwaves are powerful enough to weaken and topple buildings. Falling debris is what can injure or kill people. So one can only hope that there were no occupants in this car. And clearly, this house here was not built to withstand an earthquake and the resulting shockwaves. The shaking of the earth can also lead to other damaging natural disasters. For example, a tsunami is a giant wave caused by an underwater earthquake. A tsunami can travel for miles and cause widespread death and destruction. I should point out just quickly, if anybody tells you that a tsunami is the same thing as a tidal wave, they are wrong. Okay? The difference is a tsunami is caused by an underwater earthquake. The flow of lava caused by a volcanic eruption can be very harmful to people. Since lava moves so slowly, people usually have time to escape. However, volcanic eruptions also cause the spewing of hot ash, gas, and rocks, which can make it hard to breathe and damage people's lungs. Lava itself can set fire to structures, which results in widespread property damage. Like an earthquake, a volcanic eruption can lead to the collapse of an area's economy. So what these folks are doing right here, sure, they may feel that they're getting a really nice view of what's going on, but they really shouldn't just be standing there watching. They should be on the move. While scientists cannot prevent earthquakes, they do have tools which can be used to study an earthquake and keep a record of earthquake activity in a region. A seismograph is a tool that measures and records the magnitude and duration of a disturbance of the ground. The magnitude is determined by the strongest seismic waves that are recorded on a seismograph. Scientists also use the Richter scale to classify earthquakes. And now I'm not going to read the entire chart for you, but what you might want to do is just put the video on pause so that you can read uh, what the various ranges on a Richter scale mean. The damage to houses and roads increases as the movement of the ground increases in size. For example, an earthquake that measures 4.0 to 4.9 on the Richter scale is considered small. It would cause a window to break or items to fall off a shelf, but not any significant damage. An earthquake that measures 7.0 or greater is considered a major earthquake. In these cases, entire buildings can be knocked off their foundations and underground pipes will break. So you can see a considerable difference between two earthquakes as shown by these pictures here. Disaster response teams can offer some advice to people living in areas of high risk. Measures of protection include having breathing masks and emergency first aid kits in the home, and having emergency supplies of food and water on hand. People will be given as much advance warning as possible, but in many cases there's no time for people to escape an earthquake, in which case they need to seek shelter and stay inside until any aftershocks have passed. Seismographs can also be used to predict volcanoes and earthquakes. When a seismograph records a series of small shocks, scientists take this as a signal of an upcoming disaster and they can alert local authorities. While humans have yet to build earthquake-proof structures, the laws in countries where earthquake activity is common requires buildings to be more resistant to earthquake damage. As a result, architects are now using different materials to build improved structures. Engineers have developed new building materials that can bend instead of break. Walls are supported by braces that help them resist shaking and collapsing. Whole buildings, such as the Transamerica Building in San Francisco, have been designed with flexible bases to absorb shock waves. Okay, so we're going to end this video uh, by looking at these two questions here at home, and then we'll discuss our feelings on these questions in tomorrow's class. So question number one says, do you think that people who live in areas that have a lot of volcanic or earthquake activity should be made to move to another area? And two, what things do you think can be done to help protect people from volcanic eruptions or earthquakes? So what you need to do is put the video on pause so that you can reread these questions, write down your thoughts, because I do want to hear them in tomorrow's class. If you're struggling with these two questions, I want you to go back and watch this video at least 2 more times, and then you can put the video on pause, write down your responses to these two questions so that we can have a nice discussion at the start of tomorrow's class. Please put the video on pause right now. And until tomorrow's class, where we will discuss your answers to these two questions, this concludes today's video.